You know, something that I forgot to say is LEED is a voluntary nonprofit organization. It might not seem so much when you look at the costs of everything, but it is not a government entity. Most everything, including the LEED rating system, was developed by volunteers like me, so we didn't get paid to do this. We just donated our time and expertise to put this organization and these rating systems together. And I think it's up to all of us to keep making it a more vital system, keep making it more tailored to the issues in our local areas. So we need a lot more people involved in the whole concept. I'll wait just one more second for most of these people to come in. So this next category is energy and atmosphere credits. There was a movement in the United States early on when we had a lot of high oil costs to do energy conservation. And a lot of those people never gave up the fight to try to make things more energy efficient, and they've rolled some of their efforts into LEED, and so that's why there's a huge concentration of credits under energy and atmosphere. But it's just felt that in general our production of energy is fossil fuel based, and it is causing climate change in a very negative way throughout the world. And we need to do as many things as we can to make our energy go further and to reduce the emissions from energy production. So there are 3 different prerequisites within energy and atmosphere, and each one of those prerequisites also has points related to it. I just talked about, we have coal-burning power plants for the most part in the United States. That's making a whole lot of contamination of our waterways, mercury and asthma and all kinds of different pollution effects are happening. I'm hoping I don't have to explain too much about the nuclear power industry, but we've had a tremendous amount of lobbying by the nuclear power industry throughout the world, trying to build nuclear power plants and saying it's the most efficient and least polluting system there is. But I challenge you to talk to the people of Japan right now about the pollution effects. I mean, we just have not figured out a really safe way to minimize radiation pollution and the effects when things go wrong with nuclear power plants. So I think we need to rethink energy use across the board and come up with some better solutions than using all of these methods that are ruining the quality of life for the earth. So with LEED, we're trying to get you to think in an integrated team approach to thinking about the energy use in a building. And the first place to start is to minimize the need for energy. I guess I'll go into that in a minute. The first prerequisite within the energy category has to do with building systems commissioning. I don't know that it's the case in Mexico, but in the United States, a long time ago, we used to be able to have engineers work on projects all the way through the design and through the construction. And in our never-ending need to reduce fees and reduce the cost of construction, we kept eliminating little portions of engineers' work and architects' work so that they don't always work on all parts of the project. So the engineers would design something quite good, but they weren't always around to see if it got built the way they designed it, or to see if it functioned the way it was supposed to. So LEED started using this concept called commissioning. And commissioning is a term that was actually developed by the Navy. When they would build a ship, they wanted to make sure that sailors didn't sink. So they would send the ship out into the ocean to see if it worked and if it floated and if it could bring people back without drowning them. That was called commissioning. So we do that with buildings. Before we put the occupants in them, we want to make sure that all the building systems are built the way they were designed and that they're functioning properly. And many times we just leave that step out to see if everything's working properly. And we know buildings are going to get commissioned one way or the other. It's either by the occupants putting up a piece of tape over their vent, or putting up a newspaper over their window because they're too hot, something like that. It's going to get commissioned. So it might as well be at the beginning of the project before people get into it. So this is a systematic approach to running the building through all of the systems, including if you were to have rainwater collection, making sure that works, but making sure the mechanical system and the electrical systems worked. For fundamental building commissioning, the commissioning agent would need to review the plans of the systems and the specifications of the systems, and then they will write their commissioning plan and write a commissioning report after they test everything and make sure it's done. So that's a prerequisite. You don't get any points for that, but then if you'd like to get points, you can go further and make sure that this commissioning agent is involved in the design process so that they know intimately what is expected in the process. They not only do the commissioning, but they train the people who are going to be working in the building on how the system is supposed to work. And they write a manual, and they come back a year later and recommission, so making sure it's working the way it was supposed to a year later. So there's additional work for this same person to come back and review. The second prerequisite is minimum energy performance, and we have this organization in the United States, and I understand it's actually international because many countries haven't gotten around to having their own professional engineering organizations to create standards for comfort and heating and cooling. So for ASHRAE, for LEED, we rely on this engineering organization called ASHRAE, who has developed standards for heating and cooling, and they have a standard for the energy performance of a building called ASHRAE 90.1. And you must meet the requirements of ASHRAE 90.1 to get the prerequisite. There are two different ways to do this. Either follow a checklist of different items that you've put in, like how much insulation you've put in, how much the square footage of windows versus walls, what the efficiency of your equipment is, that kind of thing. So there's a prescriptive method. And then there's I'm not going to go into energy cost budget method, but there's there's another concept called energy modeling, where you have software that designs a theoretical building, and then you compare that theoretical building, which is building code, or in this case, ASHRAE. Many cities in the United States have building codes that require energy codes. So it's what you can do legally versus what your new design would do, and so how much better performing your new design is. So there's a software program, there's at least 50 different software programs that you can use to help comply with, to show your demonstration of compliance to this ASHRAE standard. What you would want to consider is, I think that I think number 2 should be the first thing that you consider. Free energy. Can we make this space comfortable? Can you read and do all your functions with natural light instead of having to have lights on all the time? Because we know that people just don't take responsibility to turn lights off even when they don't need it. They just don't take that initiative. So could we get by with natural ventilation? I mean, here in Mexico City, you've got a pretty temperate place. You have a pretty comfortable situation a lot of the year where you don't really need assistance with heating and cooling. So can you take advantage of that? Can you build a building to shade you in the summer and keep you warm in the winter without mechanical assistance? There are different ways, passive solar design, different ways to orient your building on your site to make use of free energy. Then any equipment that you have and any building envelope that you have, you would just want to make it so that you don't have to demand electricity to make the place function. And then if you do have to put equipment in, make it high efficiency equipment. There's a variety of options there. You can either buy the cheapest thing, the right off the shelf thing, or you can look a little further and find something a lot more efficient. It's up to you. It's out there. The third prerequisite has to do with the gases used in heating and cooling and refrigeration devices. And I can't remember, when I first started coming here, I know Mexico still allowed CFCs, but didn't you recently pass a law that prohibits CFC use? Anybody? No engineers in here? Maybe you didn't. Maybe you still allow CFCs. You're one of the few countries in the world that does. But that's unfortunate because CFCs are known to directly affect the ozone layers of the world. So for the prerequisite, so to do a LEED project, you cannot have CFCs in refrigeration or cooling, so air conditioning. So either in refrigerators or air conditioners. So you have to build a building without that. And there are items on the market that help you with that. There's a credit that goes a step further than to say there's such a thing. CFCs were chlorofluorocarbons and HCFCs are hydrochlorofluorocarbons. All of these gases are used for propellants and also keeping things cool. And there are a number of different propellants out there now that can replace these ozone depleting propellants. So anyway, there are options out there, and LEED prohibits the use of CFCs, and they give you points for avoiding HCFCs. It's probably more information than you need to know, but just know that there are options to use fewer or no ozone depleting gases in to make your building function. The second credit is renewable energy. So on site, you generate your own electricity. These wind turbines in the middle are probably not so on-site friendly. They need to be a little smaller than that to be wind, but I know that there's certain portions of Mexico that are wind tunnels. You can look at wind maps and know where wind might be likely. And so that's where you would use on-site wind generation. If you don't have that, I know that Mexico has plenty of sun, and so another option might be photovoltaics or solar panels. Another place, if you have some high mountain streams, you might have enough volume for streams to use small turbine hydroelectricity. So you can have your building run off of stream power, a small generation which won't interfere with the natural flow of the stream. I saw that in Ireland of all places, which is kind of a flat town, flat country, but they had a couple of places where there was some streams coming off of mountains that would power these small villages and farms. In Europe, it is becoming very common to see building integrated photovoltaics. So they're part of the building skin or part of the roof system. So they're all very integrated instead of just applied to the roof or applied to the ground off the building. Measurement and verification. This is the reason why this is in here is because a lot of times we build things and then we don't really pay attention to whether it's really functioning the way it was designed 5 years down the road. And this is building in some meters or computers within your building to be able to track your energy use over time and indicate to you if something's going wrong. So if you had planned a certain amount of watts for your lighting, for instance, and then 2 years down the road, all of a sudden you're using all sorts of electricity for lighting, this measurement and verification protocol, there's a whole system involved in it, will help you identify what might be happening and what you might do for corrective measurements. Some of this can be pretty costly if you have a small building. This can be pretty costly equipment. But if you have a large building, it can really help you save money to help you identify where the electricity is being used and where it's being wasted. So you no longer have to go to someplace else in the world to purchase green power. This is to either purchase the power to run your building, or there's something called a renewable energy credit that you can purchase. That means you're not using it directly in your building, but you're offsetting your electricity by helping to promote this wind generation plant somewhere else. It's kind of it's like carbon trading or something. But there's two different ways to get this credit, either directly buying power from a renewable energy source or buying the renewable energy credit. Way too much information, but I think that the renewablechoice.com will help you find a broker even in Mexico if you don't already know of brokers for green power. So with green power, there's two different things. You either supply your own power on your own site, or you offset that power and get it from the grid or purchase the renewable energy credit. So with these energy and atmosphere credits, there were a whopping 35 points that you could get. So there's a lot more emphasis in this than, say, water or sites. The next category is materials and resources. This is the thing that a lot of architects focus on because this is what they do. I mean, they know how to specify materials. There are points here about materials themselves where we're trying to minimize waste in the manufacture of materials and trying to make a wise choice in materials and trying to use materials that don't use up a lot of embodied energy. Are you familiar with that term? It's not just the energy that it takes to make something function, it's all the energy it takes and natural resources it takes to produce and use the material over time. So we're trying to look at embodied energy in materials and reduce that amount. In the future versions of LEED, there is going to be a much stronger concentration in environmental footprint or embodied energy of material use. We're working with, I think it's ISO, the International Standards Organization, to come up with embodied energy standards and just in general material standards, and it's been quite a long road to hoe here to try to get this international standard to take place. Everyone has their own measurement technique about, oh, well, do we measure how far the workers have to drive to the mine, and then how far the mine is away from the factory? I mean, nobody knows exactly where to measure from or where to start from in measuring their environmental responsibility. So we're coming up with some international standards of where we can all agree are the stopping points and measuring points for environmental responsibility of material production. So stay tuned. That's going to be the next new thing in LEED. So we're trying to reduce the impact on natural resource consumption and also be more mindful during construction. So these are the 7 categories. Oops. Advanced too quickly. Storage and collection of recyclables. Now, you have a legendary landfill here in Mexico City. I understand it's huge. At some point, I'd like to go see it someday. But anyway, we're trying to encourage people to recycle within their business and to sort their materials in their business, so it makes it easier to separate and send those off to places that can be reused. And I understand that there actually is a neighborhood here in Mexico City that started a recycling system, and within 4 days they had diverted 4 tons of garbage from the landfill. I mean, that's pretty significant for one little neighborhood. And so they're trying to make that happen all over Mexico City now. But it's going to take source separation so that you have, I think they do it here in this university. You have paper, cardboard, plastic, aluminum, that kind of thing. So this is a prerequisite with LEED that you have to make this effort to recycle within your site. And I know this used to be a difficult thing for buildings in Mexico City, but it's not anymore. I don't think you have any excuses anymore. You can do this now. So this will help with the waste management issue that we all face. The first credit is building reuse. And in my mind, the greenest building is one we don't build. Let's reuse what we have. I'm not sure what adaptive reuse we can make of pyramids, but somebody's probably thought of it before. We can figure out a way to reuse this. The way we measure this is by physically measuring the walls and measuring the ceiling and measuring the floor. So that means you don't have to reuse all of the building. You can maybe knock out one of the walls and add on to it or something, but reuse as much of the building, of an existing building, as possible. There's a second point for reusing interior sections of a building. So maybe you're using the envelope of a building and you're not using most of it inside, but if you take some of the partition walls and maybe there was an acoustical ceiling that you could use or some of the flooring that you can reuse, that can help you get this extra point, maintaining interior non-structural elements. During construction, we know a lot of construction waste goes to the landfill. And so, again, we're starting to look for ways to divert materials, to reuse construction materials and use them more mindfully, even in other building projects or for someone else's use. So for instance, on one of my projects, we were building a new airport, and we took up all of the concrete and ground that concrete back up and put that concrete back down. I'll back up a little bit. We had to pull up the concrete because there was toxic waste buried under that concrete. So we had to get to the toxic waste, pull it up, remediate that, and then put the concrete back down, which was something we hadn't planned. We thought, oh, good, we have all this concrete, we can land planes on it. But anyway, we ground up all of that concrete. We used all of that again in a new concrete mix. So going the extra mile to think up ways to reuse the materials is going to help with your landfill size, as well as it can help with your cost to haul away your materials. Because maybe you can find a home of something really close. The metals, some people might want to come and claim the metals. Some people might want to come and grind up the concrete and take cardboard away. There's markets for these things. So you get up to 2 points for construction waste management, for diverting up to 75% of your materials. If you divert more, you can get a 3rd point. By many of these credits, if you exceed the thresholds, you get an exemplary performance credit. So you could get an exemplary performance credit for this. These materials credits, it was really hard. This was many, many meetings worth of trying to figure out, well, how would we measure how responsible a building's building with materials. And the only way we could figure it out, because it was difficult to compare one building's materials to another building's materials and say, well, which one was better? One building might be huge and the other one building might be little, and what if the little building used some really horrible materials, but the building, so anyway. So what we decided was to measure this by percent of the cost of the materials. So the total cost for the building materials, this doesn't include labor. We have to get that figure, which has been difficult, I gotta say, to get the general contractor to give us a just materials figure, because many contractors, when they're bidding on, say, the wall system, they bid on everything, the paint, the wall, the labor all together, and to try to get them to break that out has been a bit of a challenge with LEED, but we've been able to do it on projects to try to get this more fair way of measuring the responsibility of materials. So these next several credits are a monetary achievement. So the more of your construction budget that has these attributes, the better. So resource reuse is a term, I actually use the word salvaged. Is that a more common term here? Salvaged building material. So it's materials that were used in a different place, in a different building, on a different use. So in this case, they were going to build, on the far right-hand corner, they were going to build walls around this building, and they were doing a demolition of a big parking lot next door. So we got them to cut up the parking lot into some squares. We've tilted those up and put them, instead of that we use those for these walls. A friend of mine calls this urbanite. So it's urban refuse being used again and stretching out its life. The building, the picture in the middle is ground up concrete and ground up aggregate to be used back into, or you can just reuse it as a gravel on your site. I don't need to tell you more about that. One of the simplest things to do now is to specify materials with recycled content. When I was first starting in this industry, I would call up people and say, do you have, I specifically remember calling the Armstrong ceiling tile representative and saying, is there anything recycled in your material? Because I had read that they grind up newspaper and put that in this, and he goes, no ma'am, we don't have any of that bad stuff in our material. because he didn't want to admit that they did this. And the next year, when he realized that people, I was going, well, that's really too bad, because I'm really looking for materials that have that. All of a sudden, Armstrong started marketing the fact that they have 90% recycled content in their materials, and they're very proud of it, and other people started catching on. And so it's actually difficult to find materials that don't have some component of recycled content in their product. And it doesn't have to be 100%, it can just be a portion. For recycled content, we have two different kinds of recycled content. We have, I don't know if I have, oh, nope, I thought I had a slide. We have recycled content before it goes out to consumers, so before it gets off into the world, so it goes from one industry to another industry. That's called pre-consumer recycled content. And then we have the recycled content that is called post-consumer recycled content. That's like one of the plastic bottles that gets melted down and made into carpet. So that's called post-consumer. And we value in LEED post-consumer recycled content more than pre-consumer recycled content, because it's not traveling as far, it doesn't have as many uses. There's some intellectual discussions about that, believe me. Okay, there's a couple of points for buying local. Trying to stimulate your local economy is really important. This is really important to your nation, to try to keep people working here and making things useful for you to use. And so we're asking you in LEED to specify things that are manufactured. In our case, we're saying 500 miles away from your site. So things that are extracted, so that means mined or harvested, so trees or something like that, harvested or mined and manufactured within 500 miles of your project. And I know Mexico City has a lot of manufacturing. You can try this. Let me see. This one friend of mine feels strongly about the local aesthetic, that you're reusing materials or using local materials which help identify you as a culture. And I think that's important to cultures, to keep using their own things instead of buying something from, I don't know, Orlando, Florida or something. It also helps, one of the things behind this is transportation cost. There are so many items like stone that are quarried in Asia, and then they're shipped to Italy to be cut, and then they're brought here to be used, where you might have some wonderful stone here in Mexico that didn't have to travel all the way around the world to get here. But the problem is they used slave labor to do, make that, and they're not employing the people locally. And it just also represents the amount of subsidies we put on the transportation industry internationally. Governments pay a lot in subsidies to the shipping industry. We'd like that to stop because it's wasting a lot of energy. Another thing that I think isn't used enough in LEED is rapidly renewable materials. This is using materials that are grown or harvested within a 10-year cycle. So things like wool carpet, or Raul de Villafranca's specialty bamboo. You could use bamboo in construction. He uses bamboo for structure, which is an unusual thing and a really wonderful material, isn't it? It's beautiful too. Someday you really need to give me a slide of one of your restaurants or something, because, okay, good, I want that. because they're really beautiful. I'd like to have that instead of this bamboo forest. Because I don't believe, I really am not an advocate of using bamboo flooring that's made in China, and it's got, it's got its own transportation issues. If there's something you can harvest here and use it here, this is really important. The material credit that's probably one of the more controversial is certified wood. We have been trying to come up with a better standard than just using Forest Stewardship practices, Forest Stewardship Council, which is called FSC wood, which is the only thing that you can use now for LEED credits. It's an international organization that is responsible for tracking the sustainability of the growth and harvesting and manufacturing process to make sure that no, I guess I'll call it inferior wood is introduced, or wood that is not sustainably harvested. For instance, a clear cutting situation, which degrades water, causes pollution. There's a lot of problems, ruins habitat. FSC is a whole system to try to protect forests and to try to provide us with the wood we want to. And so FSC is what we use, even though there are a number of other options out there. This one we feel has the most integrity of the systems. So there are 14 possible points within the materials category. Pollutants and indoor environmental quality. This isn't just indoor environmental air quality. This is looking at some of the bigger pictures of the indoor environment, looking at worker productivity, because the more comfortable and healthy you do an interior, the more people want to be there and work productively, according to studies. I can't tell you exactly the percentages, and I have a feeling this might have to do with culture as well, but we're trying to make healthier atmosphere to make workers happier in their building. So there are two different prerequisites here. The first one has to do with fresh air, getting oxygen into your building. Even if you have a naturally ventilated building, you will need to demonstrate that you don't have stagnant air in the room, that you've done something to cause convection to give an air exchange in your room, which is a good idea, and it also helps keep the temperature moderated as well. So having more oxygen in the room means that people can think better, think clearer, and they feel better. The second prerequisite, well, I guess it's prerequisite one, has to do with making sure that there's enough oxygen, making sure that there are measures taken within the building to minimize pollution coming into the building, so that you've taken fresh air out some way and either naturally treated it, so by convection, or filtered it in some way to bring in fresh air and oxygen and delivering clean air to people. There are a number of different ways to do that. Sometimes it's a real challenge in a very high humidity place. So in this case, this picture here, it's kind of hard to see what this picture is, but you see there's hands down there in the bottom of the picture. That's a giant desiccant wheel, and that means that the air is pulled through that big wheel, and it's wrung out, it wrings out the moisture in it, so it dries out the air, and it takes that moisture and does other things with it. It can pre-treat incoming air and all kinds of different things. But anyway, it can also, so it moderates the moisture in the air, and it also helps with energy efficiency, because the drier the air, the more comfortable people are. The second prerequisite is to have no smoking in the building. And I know this used to be a challenge in Mexico City, but I gather a couple of years ago you had a new law passed, right? About no smoking in businesses, right? So this is a good thing. With LEED, they ask you to make a provision for all those people who do need to smoke, though. So you either, you need to have some place away from the doors and windows of the building for smokers to smoke safely and without that smoke coming into the building. Or there is a new provision that says no smoking anywhere on the campus. So they'll allow that too. But they knew that they're going to be smokers, so they wanted to make a provision for them. Okay, the first credit is about carbon dioxide monitoring. It's just known that the more people you have in a space, the more we're breathing. And the more we're breathing, the more we create carbon dioxide. And that starts affecting our brain. If we get too much, we can't think very clearly, and we all get sleepy. And I notice a lot of you sleepy right now, and I know it has nothing to do with my presentation. It's got to have something to do with the carbon dioxide in this space. I don't know that, but I'm hoping. Anyway, so this is having some sort of measuring devices to measure the carbon dioxide. And if the carbon dioxide gets too high, like it often does in an auditorium, that it kicks in some sort of fresh air device, and that fresh air will be blown into the space. Credit 2, increase ventilation effectiveness. There are some fancy ways to deal with this and some not fancy ways to deal with this. What this means is, in this room, most all of us are breathing So it's kind of weird, or a waste of energy, to condition that area up there and or even bring oxygen up there. I mean, we don't really need it. We need it down here where we are and where we're breathing. So there's this thing called displacement ventilation, where you introduce the air here and you don't care about what happens up there. So you're not trying to move this massive volume of air around. This not only helps with oxygen and breathing, it also helps with energy efficiency. A couple different ways to do that. This one over here is the raised floor that a lot of people think is really sexy. It can be kind of expensive to do and not necessary. It could be a good idea depending on your building. Okay, during construction, the construction workers can do irreparable harm or eternal good, depending on the air quality of the building, depending on what they do while it's being constructed. If they're smoking a lot of cigarettes during construction, what does that do? You can't get rid of that. It permeates the walls, and it's going to affect the indoor air quality. During construction, there is a guideline to keep the place clean during construction and to make sure that dust doesn't get into the ventilation system, that materials are covered so they don't get wet and mold during construction, or that they don't get really dusty. And then, I mean, I don't know if you've ever been around gypsum board when they're cutting it. I mean, it's this fine white dust that gets into absolutely everything. And that dust will continue to get out into the breathing zone of people if you don't take care of it during construction. So we try to keep the place clean. That's all you're asking. It takes a bit of education to show people how to keep things covered, how to keep things closed off until needed, and also if you're going to run the ventilation system, that you keep things filtered before that you run it. There is a point for indoor air quality before the people move in. They want to make sure that there's actually clean air for them. This is a kind of a weird credit in my mind, because I feel that my projects always specify materials that aren't going to be pollutant in the long run anyway. But this is saying, well, we'll give you a point if you make sure that there's fresh air run through. It should be filtered here. Fresh air run through your building first, or that you go through your building and test for pollutant, indoor air quality or pollutants. So you want to test for formaldehyde, volatile organic compounds with these different testing devices. So you can either flush out the building or test for indoor air quality before the occupants get in. Either one, and you get a point. It's just safeguard. There are 4 points for low-emitting materials. And again, this used to be a hard thing to do. There used to be a real problem in finding materials that weren't going to be polluting the indoor air quality later. A lot of materials had these solvents in them to make them dry faster when they used. So adhesives and sealants had solvents that were there for the purpose of making them dry quickly so they weren't tacky later on. Or paints and coatings had things like mildewcides in them to allow them to stay on the shelf a long time. The first generation of a lot of these materials that came off that were low-emitting materials were sort of inferior. They didn't perform very well. Like painters would complain that they didn't glide on as easily and that kind of thing. But I think a lot of these hurdles have been overcome, and a lot of the major manufacturers know how to manufacture things that are not going to emit harmful chemicals to the occupants. And I met with a woman here at lunch who's a architect and LEED consultant here in Mexico City, and she said that she's worked with a number of paint manufacturers here in Mexico City to make no VOC paints and in wonderful colors, and I know that they're available here, in other words. We use this really esoteric standard for these because the only place in the world that bothered to come up with standards for volatile organic compounds is the state of California. And they did that because they were having so many they were having to pay so many fines in air pollution. In the United States, we actually fine cities for polluting. And they were having to pay so many fines that they decided, you know, it can't just be cars, it's got to be other things that are emitting compounds into the air causing pollution. So they looked at everything. They looked at mechanical shops and paint and body shops and dry cleaners and just every sort of process, and they came up with these acceptable thresholds. And so now if you have a product and you want to sell it in California, it has to comply with this. So everybody who manufactures stuff wants to sell stuff in California. So they all go by this rule. So there are these thresholds that are these California thresholds. We also have something for paints and coatings called Green Seal Standard, which again is many chemical compounds can't be present, and it can't emit high volatile organic compounds. For interior paints and coatings, you can get an innovation credit for also choosing low volatile organic compounds on your exterior coatings and adhesives. There's a system called the Carpet and Rug Institute, which is, in my mind, kind of the fox guarding the hen house. I don't know if you're familiar with that term, but this is an industry standard for it's the carpet industry coming up with their own standard, because they didn't want anybody else telling them what standard they could have. So in my mind, it's still kind of a high tolerance. I think it should be more strict than what they allow, but they really did start paying attention to how many chemicals the carpet industry could emit. I didn't realize that sometime in the 1980s, internationally, carpets stopped being woven and they started being glued. And that's where we started running into problems with those glues and those fibers that they started using. So we got rid of all the mills that would weave things. We started sticking them together. With LEED now, we have another system for flooring. So say you don't want to put carpet down, which is lots of my buildings don't have carpet. So there's another emissions test for any of your hard surfaces. Things like ceramic tile are exempt because we feel that ceramic tiles are going to be fine no matter what. There's a number of things that are exempt. Composite wood products, we know that a lot of materials are made with taking sawdust and small dimension lumber and kind of gluing them together. We used to use a lot of this material, urea formaldehyde, which is a carcinogenic. LEED is trying to steer you away from that and use a composite fiber that uses other kinds of stuff to glue together other than urea formaldehyde. So we're looking for any kind of composite material that has a different kind of glue. Indoor chemical and pollutant source control is identifying the fact that we bring a lot of pollutants into a building on our shoes. So the first thing is to try to have some sort of a method to clean our shoes off before we get into the building. And then we also want to make sure that any sort of chemical mixing or like a janitor's closet or any other sort of chemicals, don't introduce those chemicals to the workers or occupants of the building. So they need to have their own separate ventilation system and make sure that that air in those janitor closet doesn't get out to the rest of the building. So you don't want to introduce mold. The third requirement here is a higher grade filtration system so that you're filtering out the impurities in the air. Controllability of systems. This goes back to worker productivity. Not everybody, I mean, I'm 57 years old and I have different lighting needs than somebody that works for me that's 20 years old. There are different things that in life, your body ages and you have different requirements, and two different people have different requirements for both lighting and comfort. So we found out that it's more productive for workers to be able to control their lighting. Instead of having one switch that switches on the whole building, if everyone can have a low ambient light and then control their own individual light, people are happier and they feel like they have a sense of ownership, or they feel more comfortable and therefore are more productive at work. There's some really interesting studies on that. There's also a credit for, now this is where I feel there really is a cultural bias. In the United States, ASHRAE has determined that Americans are comfortable in this really finite range of temperatures, and I think that much of the rest of the world has a much broader comfort zone for temperature. But again, this is a credit for designing for comfort of the occupants. And then this is another ASHRAE standard for comfort. So it's a pretty narrow range that ASHRAE 55 allows for you. For this credit, for these two credits, you have to meet this thermal comfort standard, and so you have to zone and prove that you're designing for that particular threshold. And then there's a credit for doing an occupant survey for their thermal comfort. How many of you have ever worked in a building or been in a situation where you have two people side by side in the same temperature and one of them's hot and one of them's cold? I mean, it happens all the time in offices. People are always saying, they're talking about, I'm cold, I'm hot, and there's all this wasted time because nobody can adjust their own temperature. So LEED gives you a point for having occupants be able to adjust their own temperature. This has shown to be huge in worker productivity. It also, believe it or not, helps with energy consumption, because sure enough, people have a pretty broad range of comfort, and one person makes up for the other person. Another thing that we as humans all like is to work in natural light. Lots of us don't like artificial light, and we like to be able to control our light, but we also like to, we really enjoy working in natural light, in daylight. And there are ways to plan your business and building to maximize your light and either maximize the heat gain or minimize the heat gain. You can control that depending on where you place your windows and where you place your monitors or clear stories. And that way you can really cut down on your electricity use and make people enjoy their space better. There are a number of different, things called monitors, clear stories. You need to make sure that people don't have glare, and there's ways to do that too, so that that's not interfering with them. No glare on computer screens, for instance. I have a lot of daylight slides because it's another one of my passions. So this is designing so that you pop the natural light back into the space, and you also shade the windows so that you don't get heat gain. It's pretty simple. We humans, as well as other animals, like to see what's going on outside. We really enjoy being able to have a contact with nature, as well as just, curiosity. We want to know, is it raining? Is it what? Is there a building on fire? Whatever. We all like to look outside. And this also helps with our stress level, to be able to gaze outside from time to time really helps people de-stress when they're working on a task. So building in views so that people can see out. You can have interior offices, and